Thank you. So I'll be showing you how you can create the fallback system that I explained earlier, the custom location AR system. So we will be using Lens Studio, the latest one, 4.55. So before we go into the project that Oscar sent you, I wanted to show you the template that enables us to have surface tracking. When you're on Lens Studio, you can look for true size object. You don't need to go into it, I'll just show you. So basically, all the logic for the surface tracking that we will be adding to our custom location AR template comes from this template. Okay, it looks like this. When you start with a true size object, there are a few examples here, but for example, like if I refresh, it was quick, so it detected the surface and then it triggered and it put the chair on it. We can try again. So here it's looking for a surface and then it sees a surface and it puts it there. So this is what we will be using in our custom location AR project. So we can go out and you can open the base project that you received. I disabled the fallback scene. This is what we'll look into later. So basically what you have on the left panel is the objects in your Lens Studio. This is what you get, pretty much almost what you get when you create a custom location AR project. When you just click on the template, it opens something like this. The only difference is that I put all my elements, the one you see here, like the Obelisk and all the sand, etc. I put it outside of this element, but that's just a detail. So when you get a custom location AR template, the main logic is in this custom locations scene object with all these scripts. And the status controller, for example, is where the script that does all the detection, etc. is written. So for example, here you can use custom location to try and test some cases. So for example, here I have location is far. So to Lens Studio, it looks like the person is not on location and they won't be able to show the custom landmarker. But you can also spoof, like you can fake that you are actually on the location and then you can see the obelisk appear. So this is something we will be able to use to just mimic the testing as if we were on location. We will look more closely on the status controller. The second part of this project that I added and that you have is this fallback scene. So this fallback scene, if I remove this, the fallback scene is all the logic that I got from the surface tracking template that I showed you. And if I disable the custom location AR logic, you will be able to trigger the surface tracking. So it did exactly like what we saw in the template. I'm actually using the plane. If you go like on the title of the preview, you can find plane if you've selected this icon. This is what I use when I work with surface tracking, because you have just this very simple plane in 3D space and you can easily find a surface. So yeah, we have these two systems that are for now completely, they don't communicate. So if I enable everything, I might have both. So I can have this scene that I just attached to a surface, and I also can trigger the location found. But the only thing is that the obelisk and all the elements in 3D, I share them between the two. So both can reference them. I don't need to put the elements twice. So now we have this scene and we want to recreate the system that I talked about earlier, which is this. So like the custom location AR template does this. On Lens Start, they will search for custom location AR, and then if the custom location AR is found, it will show it. But we want to add this timer here that is waiting for the custom location AR to show. And also this logic that asks, has the search been going on for a long time? Should I trigger the fallback scene? So this is what we're going to try to recreate. So as I said earlier, the status controller is where the main logic of the custom location AR is written. I will open status controller. Yeah. I added some comments for us to know where exactly we'll be adding elements. For example, here, these are in a script file in Lens Studio. You have all these yellow lines that are prefixed with at input or at UI. At UI is just for the UI of the component in the inspector, but the most important ones are those that are prefixed with at input, and these are actually the inputs you give to your script. Your script needs to have some parameters to work, so you give it an input. And since we have introduced this fallback scene that we will need to show and not show, this will be one of the inputs that we will need to add. So we will create a new input, and it starts with a double dash and then input. And the type of object I will be giving fallback scene here is a scene object. So I will just write scene object, and I will call it the fallback scene. I'm adding show if advanced just to be in the same section as the elements above, but it's not that important. The most important thing is to define the right type and to make it as an input. So as I said, when we decide that we exceeded the time and that we are going to use the fallback, we want to disable anything related to custom location AR. We want to enable this fallback scene. We will also need to disable the camera. This is the main camera of the custom location AR, but the fallback scene has its own main fallback camera. So we will be relying on this one and not on this one. So this camera, we will also need to disable it. So I will add it as well as an input. Again, double dash, add input, double slash, what am I saying, dash. Camera, and main camera. Again, show if advanced. And when you save and you look into the inspector, when you click on status controller, so this script is attached to status controller. It's on this component here. So when you go down, you see that the fallback scene and the main camera has appeared. They have appeared and they are expecting some input. So you can drag and drop the fallback scene and put it here, or you can click and look for fallback scene as you prefer. So I will be selecting fallback scene, give it to this as an input. Do the same thing with camera. I will be using the camera here. It's easier with camera since you may have many cameras in your scene. I would advise just dragging and dropping the camera. Just like this. So now I've given it the inputs. Now I need to work with those inputs. So if we go back to this graph, we see that we need to start the timer, which is basically the most important part of this. Starting a timer and waiting 10 seconds, and then deciding or not to show the fallback scene. So where are we going to do it? So before doing this, I'll be showing just little parts that are very important in the status controller. When it starts on awake, it will create an event that is update event. Basically, events on Lens Studio scripting they are just some like entry points under the hood on Lens Studio. They will be triggered at some points. For example, when you create an event with update event, this will be anything you bind to it, any function you bind to it will be executed when update event will be triggered. And update event is actually at each frame. So at each frame, the update function will be run. You can also have like brows lower event. So if you have someone lowering their brows, you can have smile, any type of events. For this one, we just want a function that runs at each frame. This is not something we will be working with, but it's interesting to know it. And it also initializes, so it does an initialization. And when you go and look for this function, you can look for it. It does a bunch of things, among which, binding, tracking data, setting up an initial state. So the initial state, this toggle content false, actually disables the scene. So while the lens is looking for the location, if trying to understand if they are in La Cour Carrée de Louvre or not, they won't be showing the elements, which is expected because they will be shown only when they will be placed in the right place on the Cour Carrée. So the first thing you do is hide all the elements. So you toggle the content into false. The hints also are false because you don't know yet which hint you are going to show. Is it you're far from the location? Is it you're near? Or you need the downloading is going on. So these are all type of hints that you can get through the custom location AR. And some other things like be aware, like you have this text that says be aware of your surroundings. This is in the initialization where it's shown. So here is the perfect place where to start a timer because we just initialized the script and we want to start a timer. As I said, toggling the content, hiding the content is something we're interested in as well for the fallback scene. So we will be toggling the fallback scene to false as well. We will be hiding anything related to fallback until we decide to show it. So this option doesn't exist yet, so I need to create it. And it's basically just like toggle content, but with the fallback scene. So to define a function, you just write function. The name you chose for your function, which is toggle fallback scene. You have auto-completion because you've already mentioned it in your script. You give it a status because you can toggle in, you can say, yeah, false or true, so show it or not, don't show it. We will use it to show it and to hide it, so we'll be using a status. And here I will be using the fallback scene that I passed as an input. And in order to use an input, you need to write script dot and the name of your input. The one we defined earlier was fallback scene. So all the elements you define here in inputs will be attached to the script object, and then you can access them by typing script dot the name. So this is what we'll do with fallback scene. Enabled is variable on the object of fallback scene that says if it's shown or not. So is it enabled or not? And we give it a status. If we say false, the enabled will be set to false, so it's not going to be shown. So if I save, I shouldn't have any issues. So the way you see if you have issues or not is by looking into the logger. If you don't have it, you just go in the window, in the panels section, and then you choose logger, and you will see it. So when you have issues, you get some errors here, but for now we don't have any issues, so that's good. So once I hide my fallback scene, I start the timer as I said. So let's call it start fallback timer. And again, we don't have this function, so we need to define it. So again, function, start fallback timer. And we can write our code. So if you remember, we talked about the events that we can create in Lens Studio, which is here we had the update event. We will be using the same type of objects, which are events, and we will be creating the timer with it. So we'll call it timer event. And to create, what we will need here is an event that is delayed. We want to have a delay, and after a certain delay, do something. This is how we will do this timer. The delay will be the number of seconds that we are willing to wait until we decide that we will show the fallback scene. So to create a delayed event, you type script.createEvent, and here when you open, you will have the auto-completion, and you can choose what you need. In this case, we want a delayed callback event. I choose it. And now I have this event. There are two things you do with the timer event. You bind an element to it. Binding, as I said, is just saying whatever I give as a function in this bind function will be done when this event will be triggered. So this we will see later what we will put in it. For now, we'll keep it like this. And the way you give it a delay is by calling call in reset. And in reset, you give it the number of seconds you want it to wait before triggering. So it will be 10 seconds. I'm not a big fan of typing numbers like this, so we'll use a constant. A constant is just like a variable, but it's not supposed to change. We'll call it timeout limit. And we can go up. Just after the inputs, I put this comment, define fallback specific variables. It's not a variable, but we'll define it here. We'll call it const to say it's a constant. And we will give it the name which we've just given it. So it's timeout limit. And let's say 10. So each time we'll be changing it, we will just change this constant. So yeah, timeout limit sounds like 10 seconds sounds like a good timeout limit. So yeah, now we need to bind the function. The way you bind a function is by, again, defining the function inside. You can either, like for example, I could say toggle fallback scene to, like, any function could be defined and given here. But in this case, we will define a new function. And here we want to show the fallback scene. So after this timeout limit, 10 seconds, we want to show the fallback scene. So all we need to do is toggle fallback scene, and this time instead of hiding it, we will show it. So we put true. And what it does, it's going to give true to this function. It will be giving true to enabled, so we will see the fallback scene. So if we save, do we have issues or not? Yeah. Yes, we can. Yeah, in order to test, we will go back to custom location, and here we will pretend that we didn't find the element, like the location. So let's say the location is far. So the location is far. It's still looking because we haven't exceeded 10 seconds, and then after 10 seconds, now we see that we have this search here. And then there's a bug here, but I will show you how to get rid of that. And then you look for a surface, and then it works. So we see that it does fall back after 10 seconds, but we have two issues. The small obelisk that we saw in very far, and this hint that stays there because it belongs to the custom location AR, and we didn't say don't show your hints. So another thing we need to do here is disabling the UI. So again, script.hint UI .enabled false. So we just say anything you want to show as a custom location AR template, don't show it because we have fallback in on another type of solution. So when you save, again, it's going to look for the fallback for the location for 10 seconds, and then after 10 seconds we will see. So yeah, we see the search for the fallback for the surface, but we don't have any hints from the location, custom location AR, which is good. Once you find a surface, it appears. What I said earlier, but I didn't do it, is that I wanted to disable this main camera because I have my own camera. And since I didn't do it, I had this small obelisk in far, but I can see it now. So the other thing I need to do when I decide that I will show the fallback scene is disable the main camera that is not related to the fallback scene, which I actually already added as an input. So I can go back to the fallback timer. And another thing I can do is script.mainCamera, the input I created, and remove it. So now, again, it's looking for the demo for 10 seconds. I don't see the bug I had because I removed the camera that is not used. And now I just need to look for a surface, and it will trigger the surface tracking, and there you go. So it's working. So we have this working, but we also have to handle another problem. Let's say we waited for 10 seconds, and then we triggered the fallback scene, but then the custom location AR suddenly works what is going to happen. Since we've shown this fallback scene, we will decide that custom location AR is disabled completely. So we need to tell the script to stop searching for the custom location AR. And to do so, there's a function that is called onLocationFound in the same script. And this onLocationFound is basically the function that is triggered once the location is found in the custom location AR. What it does is that it says, okay, I don't search for location anymore. It hides the hint and then it toggles content to true, which makes it visible. So it just shows all the elements it has hidden on initialization. So now, since we added this fallback scene, and in the case where the fallback scene has been shown, now we may want to make sure that searching for location is set to true. And it's a way to tell the location, the custom location AR, that it doesn't need to look for the location anymore. So in the same timer that we created earlier, timer, here we're going to change the value of searching for location to false. It makes what it does when it finds a location with the custom location AR. So searching for location is false. And once we say that it's false, the function onLocationFound that we saw earlier needs to know that as well. So here, before doing anything, it will check if searching for location is still going on. So only if searching for location is true, we will do what it does usually, which is searching for location to false, hiding the hints, and showing all the elements. So now we can guarantee that we won't have a conflict between the two. So it's either the custom location AR experience showing or the fallback scene. We can test again for a last time just to check if it didn't break the experience. Because we can test, obviously we can't test that case where it suddenly finds the custom location AR after 10 seconds because we can't mimic it on Lens Studio, but that's the kind of stuff that you test on location when you go to the location. And so it works. Now we made the two solutions cohabitate, I don't know if that's the word, but live together in the same project, and we can have both solutions depending on how the user interacts with the experience and how the device actually allows. So that's it for me.
Perfect. Thank you so much, Lubna. Thank you.
Welcome.
Okay. Thank you. Can you hear me well? Cool. So let's do some VFX then. So if you open up the project called Louvre Workshop VFX, this is what you get. So let me explain to you quickly maybe what we are going to do here. The way I was thinking it is, I think what I'm going to do is more of a walkthrough. Basically over here, like on the left, you can see in the hierarchy, I've got two folders. So I've got one called VFX Work in Progress. So this in there, they are the VFX that we are going to work on. And just below, there's a folder called the VFX Final. And in there, it's most of the VFX that are in the final project, Obelisk project. And for all of this, all these ones are basically finalized. And it's more for you later on if you want to. You can just have a look at all of them and just open them up and dig a bit more. But because we only have so much time, and this kind of exercise can take a bit of time, I think we're just gonna focus here on one main VFX, and if we've got enough time, maybe we can see another one. But and I'm not gonna build like the VFX from scratch. I think it's just easier to go basically in the VFX system. All the nodes are already there. It's just I'm gonna turn them on one by one and explain a bit what they do. Of course, if you have any question, please let me know. So we can start. Quickly, one quick tip just for navigation in Lens Studio. Usually what I do is with the trackpad and using the arrows, like the gaming keys on the keyboard. For me, it's like WASD. It's you can just move around. Like the scene is very big. It is in terms of units and scale. It is because when you when the base of the project is a custom location project, it basically uses like the real units from the scene. So like here the scene is huge basically. So all the units and values are gonna be bigger than usual. So over here we can go click there and check the camera speed and put it to fast. And then now we can navigate just a bit faster, which is more convenient for this scene. So by default it's locked on the y-axis, so you can just go there on the bottom right and you can unlock the y-axis, and which means that you can just go up and down. Same is going to be just easier to navigate. So by default, what we have in the scene, what we have turned on in the scene at the moment is the sand on the ground, the obelisk building up, and the sandfall that you can see here. It's the visual effect that we are going to build right now. So yeah, as I told you in the presentation, storytelling was, we've got the sandfall, and by falling, the sand just kind of builds up this the obelisk. So let's have a look at the, I'm gonna grab my inspector, and let's go to VFX work in progress folder on the left in the hierarchy, and we can enable the asset called VFX sandfall work in progress. So you need to enable it here, and then you can go to the inspector over here, right click, select. It's so this way it just shows you where it is in the resources. And now we can just double click and it opens up the VFX system. So it is going to be a bit tricky for me because when we are working like this, mirroring the display, like all the layout feels very busy, to say the least. So bear with me because sometimes I'm just going to have to resize the windows a bit. Okay, this is what we have in the VFX sandfall work in progress file. So yeah, sometimes for some reason, like the preview just resets, also like the camera speed and everything. So I need to go to the right position again. So you can see, like I already put the position, like the VFX in position, because we want the sand to fall from the sky just above the tip of the obelisk. I already put the VFX system in the right position. So by default, what we have is this. So like we've got some particles popping up, but that looks nothing like a sandfall at the moment. So what we can do is we can zoom in on the spawn particle model. So just very quickly, I don't know if you guys already ever worked with the VFX graph before. It's quite a powerful tool. You can do a lot of really cool stuff with it. So we've got the spawn particle model. So this is where you set the amount of particles. So that's quite important because at the moment we've got like 300 particles popping per second. And you can set also like the particle life, how long the particles are going to be on display, how long they're going to be living. And these two settings obviously are like very important because like all the performance of the VFX is going to depend on that. Obviously, you don't want to, because we all know that we're working on mobile devices, so I don't really want to put like 100,000 particles popping per second. That would be a bit crazy. So yeah, it's always a matter of like trying to strike the right balance between the amount of particles and like the life and everything, depending on what you're trying to achieve and also what's the target device. Anyway, that's for the spawn particles. So this is where the particles are born, basically. Beautiful. So let's just disable. At the moment, we just have a disk where the particles spawn. So we don't want a disk. We want something more like a torus. So you can just turn on, enable like this node that's just below, called the set position volume torus. So like you've got different kind of shapes. By default, like you could do like a cube, like a sphere. But over here, the torus is the one that I want to use. So you can see now we've got a nice 3D torus made of particles. This is cool. In there, you've got different parameters like inner radius, outer radius, so you can just change the scale of it if you want to. Cool thing is you can just see the direct feedback. So okay, let's just go back to 70. And as I told you, because I'm just doing a walkthrough, basically when I'm changing a value, you don't have to do it. It's just to show you exactly what the parameter is doing. But really, by default, most of the values are already set correctly. So the way at the moment they're just like spawning like this particle. We are going to want to animate this the way they spawn on the torus, because at the moment it is very uniform. Okay, so now you can see on the left we've got this spawn variation set of nodes. So we're gonna plug this to arc angles, or maybe I can show what the arc angles are doing. So in the parameters of the torus, we've got arc angles, and you'll see if, for example, I put like 180 here, you only get half of the torus. Like the particles are just gonna spawn on half of the torus. So by animating these values, we can get a bit of a behavior, like a bit of an animation, being this. So like the particles are being spawned like with an animation, let's say, on the torus. So this is going to be useful for the main behavior for the sandfall. At the moment we can just cut it and we can plug it back later, and then the effect that this thing does will be maybe a bit more obvious. So what we can change now is the color. Maybe it's at the moment we just have a random range between gray, dark gray, and white. We want something that looks a bit more like sand, obviously, so we can enable the node that's just the subgraph that's just above that. So we have you just create like a random range between these two colors and applies it to the particles. So we can see it's already looking a bit more like sand. And we've got, far on the left here, we've got basically two different options to give a bit more colors, in a way, color options for the sand. When you zoom in on sand, it's like so many different shapes and colors. We want to achieve that in the VFX. So a way to do that would be to feed a gradient texture and use this gradient texture to color the particles. So I can grab, for example, the thingy from this thing and put it in the color B from this subgraph. At the moment, I can see that half of my particles are pink. That's not exactly what I want. It is because when you reference, I just reference a new texture basically inside the VFX. So now if I go to the inspector, I can see like my gradient texture is asking for a texture. So I can just go grab in the resources like a texture called sand gradient. It can be interesting to have a quick look maybe at this texture. It is a bit of a weird one. It's like a horizontal 128 pixels, and all of these pixels are different color. It's just a gradient that I made in Photoshop with different shades of sand color, and only 1 pixel height, because really the only thing that's interesting here is just the pixel on the horizontal axis. So we're using a texture, but it's like a very, very light texture. Most of the time it's better if you can not to use any texture, but sometimes like it's just easier to use one, and because it's so small, it's in terms of performance, it should be okay in this case. So we can see we've got more variation in the sand. So that's cool. Okay, now let's try and make these particles fall. So to do this, we just go to the Sigon module, which is the update particle. So why the subgraph and the nodes that you're gonna plug in there, it's what's happening in the life while the particles are alive, basically. So we can just enable this subgraph called add force gravity, and you'll see it just adds. Oh yeah, sorry. Like you can go to the left, and in the hierarchy you can go to VFX Final, the folder here, and this was just to show you what we were going to build, but we can hide the VFX sandfall main, because this was the finalized version of the VFX. Okay, now we can just reset the preview and see, okay, we've got these particles falling for sure, but they're so small. So yeah, let's go back to the spawn particle module, and we can disable for now this set size subgraph and enable the one just above. Okay, so that's better. Like now the particles are much bigger, a bit too big maybe. We can also in the hierarchy, because the obelisk is kind of blocking the view at the moment, so we can just hide the obelisk folder here on the left. So this way we can see what we do a bit better. Oh yeah, sorry, that's this one. Okay, cool. So yeah, we've got. So the gravity value seems to be okay. It's really big. Like usually you would never put like 30 as a value for gravity, but as I said, because the scene is super big, in this case, specific case, it needs to be 30 or something. So it feels quite fast at the moment.
It's 30 what?
30, just 30 units.
Okay.
Just you're asking too many. No, so yeah, 30 units. Yeah, I agree that okay, that might sound a bit abstract in this case. I think yeah, what I do in this case is just like a kind of empiric, I guess. You know, just back and forth, trying different values and see what feels right. But I agree, there's no sense, I guess, maybe in this value. It's not like in 3D softwares or C4D where you have the actual centimeter like value, like the yeah, it's just a bit different. Okay, so now like it's okay, but we need to give a texture, because if you go at the very bottom of the VFX graph, you've got the output quad module. This is the third and final module. This is where we color basically the particle, color or give it a texture. At the moment, I just have a UV circle. So just each particle is a plane by default, and you're just putting like either like a texture or a color on these planes. And here I'm just drawing circles on these planes, but it's not realistic enough. So by pushing like the shift key and dragging with the mouse, you can just get this and slice like the link. And we can plug this set of nodes that's on the left, which is, I'll show you, like that's a set of nodes, again, referencing a texture, mixing like the particle color, so the one that we set in the spawn module, so like the different colors, and mixing it with a texture. I'll show you what the texture look like, but first we need to, again, we need to reference the texture. Okay, so if you go to the inspector, we can see base texture is missing something, so we're missing the smoke alpha texture that we can see here. I can just show you, if you select, it's basically just a little patch of smoke, kind of, and doesn't need to be big, so it could be actually maybe even smaller. Again, because like this particle is going to be repeated a lot of times on many particles, it's better if the texture is super small, and it doesn't need to be big most of the time. But yeah, in this case, it's fine. So we can see already it is much better in a way, because yeah, we've got this kind of nice cloudy kind of look in a way. Overall behavior of the VFX is still not really satisfying. We can really see the start and the end of the particle. It is very harsh. It's because at the moment, like, we're not animating the alpha, so we can go to the update module and turn this node called fade in, fade out. It's a pretty cool node. You can just basically set like a fade in time, like same time for the fade out. So yeah, now we can see the start of the VFX system is just much smoother, because we've got this nice gradient from 0 to 1 in the transparency. And yeah, because at the moment the way it's falling is like all very straight, which is a bit boring and not very natural looking. So to change that, we can go back to the spawn particle module, and remember, we can, very weird, sometimes I just can't pan anymore on the VFX window. Don't know why. Okay, I can now. So yeah, like this set of nodes that we saw at the very beginning, we can plug it back to arc angles parameters in the set position volume torus, and now we can see that it's just more interesting. Like if you remember, like it was animating like the torus and the way the particles were spawning on the torus and giving this looping animation, and now because of that, like we can see that just before we had like this weird kind of cylinder kind of falling, and now the particles are dancing a bit more in a way, like in the way they fall. So yeah, that looks a bit more like what we had as an example. I think that's about it for this system. And then we can have a look at another one quickly. We can have a look at the smoke vortex one, an interesting one. It's the kind of tornado that pops around the whole scene. You can see it here. And so at first it starts on the ground, and then quickly as the obelisk is popping up, building up, like the vortex is also like going up. And this is a pretty cool effect. In one VFX system, like you can really surround the user and the whole thing with it. So it gives a lot of it's a lot of value for just one very fairly simple system. You'll see. So we can just disable the final one and go to the smoke vortex work in progress one. Let's have a look. So again here, like almost all the nodes are already here, and they're all kind of enabled already. So the starting state that we have here is just this. Again, you can see the position volume is also a torus with the same smoke texture, and at the moment it's just peacefully staying on the ground like this. And one really easy way to animate this basically is just we've got this really cool subgraph called vortex, and it's situated in the update particles model. We can just turn it on, and you'll see it's quite fun. As soon as you turn it on, basically it starts doing its thing, which is like kind of playing with all the particles and attracting them in a very funky way. By default, so you've got a lot of parameters in this module. You've got the strains. This one is very important. It's like how much force you applying basically. The vortex axis is also very important, depending on which axis you're setting, like the look and the behavior will be completely different. But I think that's a very cool one because with only one subgraph you can just achieve so many different looks and animation. So it's just quite fun to play with it and play with the different value. For what we want to do, I think we just want to have the y-axis, which is like the vertical axis, and we can maybe leave the strains to 300, and I wanted to show you. Let's see if this works. I wanted to show you a way of animating this value. So at the moment, if I just leave the values like this, it's just like animating this way, but staying on the ground. And it's because we want to change the target position. The target position, we can see that here the particles are being attracted to a specific point in space. And this is where the target position, this is where you set the position of this attraction point, the center of the vortex. And let's say I could try to put it to 2000, for example, and then there you have it, like it's going up like we want to. 3000, okay, like we can pick whatever value is fun. Ultimately, I think most of the time what I'm doing is like I'm setting parameters in the VFX systems, and then I'm getting these values, these parameters in twins, and then animating using the twins. I'm animating the different parameters from the graphs, and which allows you then to create like basically a cinematic, a sequence where you just animate all of these values. Sequence, or otherwise you can just plug these twins to like behavior script, and then you can create something like interactive. And the cool thing with like these twins and behavior script is you don't need to be a developer. You don't need to know script. They are basically pre-made script. So it gives you a lot as an artist. It just gives you a lot of freedom. You don't need a developer to do like some kind of interactive behaviors. Simple one at least. And one way before animating with twins, you can already try to animate straight in the VFX system. So we've got this set of nodes, and maybe you noticed I was already using before in the VFX system like the fluctuate node, which is a cool node because it allows you to animate from start value to the end value and pick the transition time. So over here, what I want to do is the ground is 0, and I want to go up to 2000, and so yeah, because I want the vortex to go up and down. I want to animate the value. I want to find the right. Let's say I want to find the right value for the height. A quick way of animating would be using this fluctuate node. So I can tell it, okay, you're gonna animate from 0 to 2000 in over the 6 seconds, and I can just plug this in the target position, and it should just animate by itself. Yeah, at the moment something's off. Okay, at the moment it's not doing exactly what I want. By using the swizzle node is pretty cool. You can just take an input and say, okay, I'm just gonna use this vector, like this value from the input. So usually you can use it a lot with textures, because you can go to a texture and say, I'm just gonna use the alpha, for example, from the texture. And so yeah, like you can just single out values like that. Whoa. And okay, so let's do the opposite then. Nice one. Well, wait. Yeah. Okay, for some reason it was inverted. Here the swizzle, by doing this, like you can see like the input value is a single value, like a single value, and we want to feed it into a XYZ value. And the swizzle is a way to say, okay, I don't want to talk to the X or Z value. This value that I'm setting here, I'm just gonna send it to the middle one. And for some reason here it was inverted, but like by putting hex, you say, okay, this is where my value is gonna go in the output. And now this is cool. Like it's just animating like as a loop. And as I said, it's a quick way of, before even animating with twins or anything, you can just try and animate values this way. So yeah, that's it for the vortex. Something else that we can do is we've got this entry blow up VFX system here in the hierarchy. So by default, it's just running constantly. So like it's just these VFXs, I want, when the obelisk is popping up from the ground, I want some sand to pop up at the same time, because I want to have this feel as if like the obelisk is so big that it's kind of displacing all this sand around, and it's popping up quite fast. So yeah, basically I want a bit of a blow up, a bit of a sand explosion when it comes out. And also I wanted to show you how to get a parameter from the VFX animated via Twin. So yeah, you can just select this one, go inside. Again, everything is already set up in this one. It's just I want to show you what subgraph is doing that. We've got again a force. Basically, like most of the time when you want to move particles in a cool way, you want to use like a force. There's different forces. We've got the vortex one that we saw just before, but there's one called attract and repel. I'm using it a lot because you can use it to do like many behaviors. But here, for example, I'm just putting this very strong value for strength, and it's pushing like the particles outwards. So like, yeah, if we say to 0, like then nothing happens. We can just put like -500, maybe. Okay, it's too low at the moment. You need quite a strong value. So let's bring the value back to something very strong. It needs to be minus, so it's going outwards. If it's like a positive value, it's gonna attract. So again, you can do a lot of stuff. If you just attract stuff, you kind of like some particles kind of flowing, and you can see like the attract and repel node as a subgraph as this target position value in here, and by plugging like a float parameter here, you can set basically an external position for the attractor. So you can see here first position. So yeah, like by doing this, basically you could plug it. You could say, I'm gonna get the position from, like, let's say an object that's moving in the space. It could be like a sphere just moving around, and you could use this external object as a position for the attractor, and then the particles would just be attracted to this external object. So it's a way of, it's a cool way of, let's say, communicating, interacting with like foreign, like objects from in the scene. So yeah, this could be used in many cases. So, but here what we want to do is we just want to animate for a time like this, because we don't want it to animate constantly like this. So here, a very simple way of doing that would be, you'll notice in every VFX system we've got this set of nodes connected to kill particle. So there's a subgraph called kill particle, and it's helping you to kill the particles. And by connecting this set of nodes, you basically give it like an emission rate. So if you, in the inspector, if you play around, you notice you have this slider from 0 to 1. So like, 0 is like all the particles are being killed as soon as they're born, and going up to 1, like they live again. And by animating, I've got this in all my VFX system, and it's a cool way of controlling like the birth of the particles. And just by animating this value for a given time, we could then arrive to what we want, which is like this kind of sand explosion that just happens for like a split second. So for example, if you turn this on enable in VFX work in progress, we've got twins blow up, and it should do what we want. It's just popping up for a bit. Yeah, and it's because we've got two twins, and yeah, I don't know if you guys worked with twins before, but you can just set up like a value, and like a bit like the fluctuate node, like how much time it's gonna take to animate from the start value to the end value, and then you can reference. You can say on update callback, I'm just grabbing this VFX parameter and then animating this property, emission rate, and the emission rate you just set it up here. For example, like you've got this float parameter, very important to define like a script name. This is how you're gonna call this parameter, like emission rate. Then you can call it from the twin. And here is just a very simple way of doing it. It's just I've got a twin that go from 0 to 1 over a very short period of time, and straight after I've got another twin that just cuts it off, which means that the particles are we just let them live for a very short amount of time, which kind of corresponds to the blow up, the sand blow up that we wanted to do. And I think that is it. That's what I want to show you. Yeah. Thank you.